Let's start the past MCQ discussion sessions. This is session number 2, right? With this one, we are going to discuss the question number 11 to 20. Question number 11 to 20, appearing in your page number 16 and 17 of your workbook 1, right? Those are the past paper MCQs regarding the history of atom, right? Okay, let's start with the question number 11. Question number 11. See what it says. That is the ultimate question on the page number 16, right? Okay. The quantity of the electronic charge was experimentally shown by, right? Electronic charge was experimentally shown by Robert Millikan, right? By his oil drop experiment, right? That was the idea, right? So, electronic charge. What was the charge? That was 1.602 into 10 power minus 19 coulombs. Right? Experimentally shown by right? Oil drop experiment by Robert Millikan. In 1909, no? Right? That was the idea. So the E/M ratio is first introduced by the Rutherford, by the J.J. Thomson, right, as 1.76 into 10 power 8 coulombs per gram, right, and the charge of the electron is experimentally derived by Robert Millikan by his oil drop experiment, right? That was 1.602 into 10 power minus 19 coulombs, right? So the answer is Millikan, answer number 2. So answer is Millikan, the answer number 2. Right? It is a simple review for the question number 11 appearing in your tute number 6, page number 16, right? Okay. Right. Let's copy the question number 12 then. Question 12. See what it says. The charge to mass ratio of the electron was experimentally determined accurately by, yes, it was J.J. Thomson, no? Right? So about the charge to mass ratio. Also known as the E/M ratio of electrons. That value is 1.76 into 10 power 8 coulombs per gram. Right? That was actually first determined by J.J. Thomson. With use of deviation angles of those cathode rays. With use of deviation angles of the cathode rays, he was able to determine the charge to mass ratio of electrons. Right? That ratio won't depend on the gas inside tube or the cathode, the metal of the cathode used. right? It is also to be mentioned, right? This EOM ratio of cathode rays won't depend on, one can say independent of, gas used inside the cathode ray tube, and is independent of the material or metal used as the cathode. So that is common for all the matter ultimately. That was the conclusion by the Thomson. So the answer is the Thomson. That means answer number 4. Right, no? Okay, that is the review for the question number 2 of your MCQs, right? Right. Let's come up with the question number 13 then. Question number 13. See what it says. The isotopes of a given element. So this question is all about isotopes. So isotopes means what? Different atoms of same element. Different atoms of same element. Those atoms differ as the mass differs. That mass difference appears as the number of neutrons differ. Right? That is why the isotopes change with other isotopes of the same element. Right? Okay. Right. Let's go to the things there. Right. Have the same number of neutrons. Statement A says it's false. Right? With isotopes number of neutrons change. That is why the mass differs. Statement B, have the same number of protons. Yes, that is true. Right? Isotopes are atoms of same element. Same element means same number of protons. Idea is clear? Right. Statement C, have the same number of electrons. That is true, right? In considering atoms, number of electrons are equal to number of protons. As number of protons are same, number of electrons should also be the same. Number of electrons should be same with isotopes, right? Okay. So next one, have the same number of nucleons. No, that is false. Statement D, false. So what are nucleons? Nucleons are equal to number of protons plus number of neutrons. Number of protons plus number of neutrons, right? As number of neutrons change, number of nucleons also change. So this statement is false. So B and C are true. B and C are true. So answer. So this is a ABCD question. So if the A and B are true, answer number 1. B and C are true, answer number 2. Right now, that is review for the question number 30. Let's go to it. Next one, question number 40. So question number 40. See what it says. Which one of the following statements concerning a beam of electrons is true? Concerning a beam of electrons. Right? We are looking for the true statement. See, statement 1. Sorry, 1. Statement 1. It is attracted towards the cathodes. False. Right? Electrons are negatively charged. So we'll attract towards positive terminal, opposite terminal. Is the anode. Right? Second statement. It is attracted towards north magnetic poles. Number 3 says it is attracted towards south magnetic pole. It is also false. Charged particles won't attract towards any of the north or south in a magnetic field. Then they deviate perpendicular to the magnetic field. Not attracted towards any of the north or south poles, right? So the statement 2 and 3 are false. 4. It is deflected away from the anode. False. As electrons are negatively charged, they are attracted towards anode. Which are positively charged. Opposite charges get attracted. Fifth one. All of the above statements are false. That is true. As all 1, 2, 3 and 4 are false. Right? So your answer is answer number 5. Answer is answer number 5. This is question number 14 of your MCQs. Just complete the stuff. Right, let's come up with the question number 15. See, the EOM value for electrons was experimentally determined accurately by EOM ratio again. So by J.J. Thomson. That value is 1.76 into 10 power 8 coulombs per air. Right? So Millikan, Crookes, Rutherford, Marsden. None of the above. None of the above. So answer is answer number 5. Right? the EOM ratio thing. Right, no? Okay. Simple question, right? Question number 15. Let's move towards the question number 16. See what it says. The size of the atomic nucleus was first determined by. It's about the size of atomic nucleus. Now, what was the size of the atomic nucleus first of all? So take the atom like this. This is going to be the nucleus, which is positively charged. Right? So basically, in the order of 10 to power minus 50 meters. So this is the atom. Its size is equal to the power minus 10 meters. So the size of the nucleus is first determined by alpha scattering experiment. This is also known as the 𝐓𝐴 experiment, right? So, making use of alpha particle scattering, that is the idea. Making use of alpha particle scattering, right? So this was the Rutherford's nuclear model, right? Right, Rutherford. Right, no? So the size of the atomic nucleus was determined by making use of alpha particle scattering. Making use of alpha particle scattering. So answer number 1. Answer number 1. With use of deviation angles of cathode alpha particles, they were able to come up with the size of the nucleus. Right? Okay. That was the preview for the question number 16. Right. Let's come up with the question number 17. Right. See what it says. Which one of the following statements concerning the particles used by Geiger and Marsden in the experiment that provided the basis for the nucleus model of the atom is most appropriate? This is about the 𝐓𝐴 experiment, right? Right, by Rutherford, Geiger and Marsden, also known as the alpha scattering experiment, right? Okay, see what they are saying. A. Accelerated particles were used by Geiger and Marsden. No, not the accelerated particles. Just alpha particles emitted by radioactive source. In nucleus. Is used. Right? Second statement. Cathode rays were used by Geiger and Marsden. So it's false. Just alpha particles. Accelerated cathode ray particles were used. No, this was also false. Accelerated neutrons, no. So just alpha particles emitted by radioactive source is used. So answer is 5. As all 1, 2, 3, and 4 are false. Right? So answer is answer number 5. Simple stuff, right? Next one. Question number 18. Question number 18. Right? See what they are saying. Which of the following statements or statement concerning electrons is are true? This is all about electrons. See what it says. Electrons tend to move in curved path in a magnetic field. Yes, that is true. Right? Electrons deviate as those are charged in magnetic fields. Right? Normally following a curved path. Right? So that thing is true. So the statement is true. So division will be a curved path. Right? So perpendicular, but kind of a curved pathway. It's like this, no? Here two balls like this. Right? So if this is the magnetic field, north south, right? So in a three-dimensional arrangement, right? So electrons are going like this. Right? Kind of curvy movement in presence of a magnetic field. Right? Only curved path like this. Right? In a 3D magnetic field, this is what happens. Not towards any of the poles, but kind of curvy movement there. Right? Okay. The statement is true. B. As electrons are very lighter particles, they will easily change their direction of travel, as inertia is very less. That is why you ultimately see this kind of a curvy movement ultimately. Right? Okay. So that thing appears, right? When they change their path, right? Like this, ne? B I. Like this, ne? Right? So perpendicular deviation. Then simply when you are with another magnetic field here, magnetic field line here, it will curve like this. Like this. Right? Curvy path. Right? Okay. B. Electrons have both particle and wave properties. This is also true. Right? Electrons are with both particle and wave properties. Simultaneously. Alright. So de Broglie's hypothesis. Right. Statement C. Electrons cannot be added to or received from an atom. That is false. That is false. So electrons will be added to atoms when forming anions, negative ions. Electrons will be emitted by atoms when forming cations, positive ions. So electron can be added as well as emitted from atoms. Statement D. The speed of electrons is equal to speed of light. That is false. Electron is with a non-zero mass. So electrons are with non-zero mass. So any particle with a mass, right, travels in speeds less than speed of light. Less than speed of light. Right now? So statement is false. So only A and B are true. So it's a ABCD question. So answer should be answer number 1. When A and B are true, answer number 1. B and C, number 2. C and D, number 3. D and A, number 4. And any other choice, number 5. So as A and B are true, answer number 1. Right? Okay, so complete the stuff there. That was the review for the question number 18. Let's come up with the question number 19. Right, question number 19. What it says? Chemical and physical properties of isotopes are similar. And this is about the isotopes. No? Again, I am telling you, isotopes are different elements. Sorry, different atoms of same element. Different atoms of same element. Why they differ? As number of neutrons differ. One can say as mass differ. But those are atoms of same element. Same element means number of protons won't change. Remember that. So that as protons are equal to the number of electrons for an atom, electrons also won't change. Right? So as mass differs, physical properties differ. Physical properties differ. Physical properties. Properties associated with the mass. Some examples: density, no, associated with mass. Melting points, boiling points. So it is hard to melt a substance when the mass is high. Melting means you are to convert a solid to liquid. Boiling means you have to convert a liquid to gas. There what happens? So in a solid the particles are very closely packed. In a liquid, which space there are between the particles. In a gas, more space there between particles. So when a melting is or kind of a boiling is done, what you are doing is actually putting the particles apart from each other. Putting the particles apart from each other. So for that, mass matters. When you are heavy, it is hard to put the particles apart from each other. So you need to apply high thermal energy, high temperature. So melting points as well as the boiling points will increase when the mass is high. So when the mass differs, boiling points, melting points also differ. Those are also referred to as physical properties then. Properties associated with the mass. Right? Right? But as you are coming with the same number of electrons, that means the electronic structure is same. Electronic structure is same. So that the electron configuration is same. So chemical properties won't change. Same electronic structure appears, so chemical properties won't change. Chemical properties are same. With isotopes, the chemical properties are same. With carbon 12, carbon 13, carbon 14 isotopes, the chemical properties are same. With hydrogen, the protium, deuterium, tritium, the chemical properties are same, even though the boiling points, densities, melting points differ. Right? That means chemical reactivity, bonding nature. Right? Same. Right? These are things you should know about the isotopes, right? Let's come up with the answer with this knowledge. Chemical and physical properties of isotopes are similar. No, that is false. Statement. First statement is false. Right? Physical properties change as mass changes, right? Second statement. Isotopes have the same number of protons but different number of neutrons. That is true. This is true. Same number of protons as you are dealing with the same element. Different number of neutrons, that is why the mass changes. Right? First statement false, second statement true. So first statement, second statement kind of a problem. If both are correct, the answers could be 1 or 2. If first one is true and the second one is false, answer number 3. If the first one is false and second one is true, answer number 4. Here, the answer is answer number 4. As is the first statement, second statement question. Right now? So complete the stuff. This is the review for the question number 19. Right. Let's come to the question number 20. Question number 20. See what it says. Which of the following gets deflect when moving across a magnetic field? Right. So it's all about deviation in magnetic field. So simple idea is any particle with a charge will deviate perpendicular to the magnetic field when they are traveling across the magnetic field. Right? Any particle with a mass will deviate. Right? If the particle is without a charge, no deviation or no deflection in a magnetic field. Right? Okay. So the things there are neutron, cathode rays, protons, and helium atoms. Right? You have to think of those things. Say you have the North Pole here and the South Pole here. This is magnetic field, right? Neutrons. Neutrons are chargeless particles. Neutrons are chargeless particles. So go to the field without a deviation. As neutrons are chargeless. Then cathode rays. Cathode rays are electrons. Negligibly charged. Negligibly charged. So what will happen? In a magnetic field, it will deviate perpendicular to the field. So it's like this, no? Right? Deviate perpendicular field. Right? Perpendicular deviation. Deviate perpendicular to the magnetic field. Right? Okay. Then protons. Protons are also charged particles. So protons deviate as opposite. to the deviation of the electrons because protons are positively charged. Opposite as the electrons. Right. With perpendicular deviation. Final stuff is helium atoms, right here. Helium atoms. So no deviation there. This atom chargelessness. Right, no deviation. The chargeless particles with no deviation in magnetic field. So A won't deviate, B deviates, C deviates, and D won't. So we are looking for the particles which will get deflected, right? So B and C, B and C. So answer is this ABCD one. So if the A and B are true, number one, B and C are true, number two. Answer is answer number two. Right? Okay. So complete the stuff. So that is the review for the question number 20. Any charged particle will deviate. If this was helium plus, yes, there is a deviation as protons towards that side. If it is a Cl minus, yes, a deviation, like in cathode rays. But chargeless particles won't have. CO2 won't deviate like that. Okay. So this is all. This is all you should know about the deviations of charged particles in magnetic field. Right? What matters is a charge. If you are charged, it deflected. If you're not, no deviation. Right? Okay. So that's all for the today's small discussion, right? So that is all about the question number 11 to 20. The second discussion we had done like this, right? So we'll meet with the third one to discuss about the question number 21 to the 30th of these MCQs. See you then. Until then, goodbye.